we are given the following patterns. So let me draw the patterns. These are created using toothpicks. Okay, so this is considered as one pick is used. There's no connection here. 2 and 3. This is the first figure. The second figure, we're going to use some freehand here. And you have a connection like that. The third one, now we are asked to draw the fourth one. See, on observation, this is made up of 3 toothpicks. Okay, that is immaterial to draw the fourth one. But clearly I see one triangle here. One triangle here. I see 2 triangles here. I see 1, 2, 3. Of course, I'm not considering the one in the center. I'm not considering these in the center. So the next one should obviously have 4. So it's going to be my 1. It's going to be my 2, my 3, and my 4. Now in 3 triangles you have 2 in between. Now in 4 triangles you have 3 in between. In 2 triangles you have 1 in between. So obviously my pattern is correct. Right, so this is the figure 4. This is 3, this is 2, this is 1. Okay. Now that would fetch you 2 marks. Now this is a big question. Let me draw the table for this. Okay, and the perimeter, we have to get the perimeter. Perimeter is this region around this figure. So 1, 2, 3. Perimeter is 3. The second figure, how many toothpicks have been used? 1, 2, 3, then 1, 2, 3, 4, 5, 6 and 7. So we are counting all the toothpicks, 7. And perimeter, we will just go around the figure, we will not go inside the figure. Okay, so it's 1, 2, 3, 4, 5. So similarly the third one, how many toothpicks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And the perimeter is 1. I have to start from here. 1, 2, 3, 4, 5, 6 and 7. That's perimeter 7. Okay, so now they are asking for figure 4. And then they are giving us some dots, and then they want us to find the number here, 127. These values we need to find, and finally for n. Okay, so now let us handle this sequence 3, 7, 11. So what is the difference between 3 and 7? 4. Difference between 7 and 11? 4. So the common difference is 4. The first term is 3. So if I want to get the fourth term, right, so I will have to use a positive n minus 1 into d, which is 3 positive 4 minus 1 into d is 4. So this is equal to 3. 4 negative 1 is 3 times 4, which is 3 positive 12 is equal to 15. So figure 4 has got 15 toothpicks. So let us check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Correct. Okay. Now, next is, if a figure has got 127 toothpicks, which number would it occur at? Okay, because 15 toothpicks is our fourth figure. They want us to give what would be the position of a figure which has got 127 toothpicks. Okay, so that means we would have to find the value of n. Okay, so we got 127 over here and 3 is over here. N we need to find, and the value of d is 4. I hope you're watching this. So they want us to give this or find this number n. So this is nothing but 3 plus 4 times n negative 4, which is going to be negative 1 positive 4n is equal to 127, which means 128 is equal to 4n. Therefore n is equal to 128 divided by 4. 4 divides here 3 times, 4 divides here 2 times. So n is equal to 32. So my 32nd figure will have 127 toothpicks. Okay. Now we need to fill in two values. We need to get this value and we need to get this value. So these two values we need to get. Now over here this sequence is 3, 5, 7. The sequence is what? 3, 5, 7. The number of differences between 3 and 5 is 2. Between 5 and 7 is 2. So my D is 2. My A is 3. So I want to get the number of toothpicks for position 4. Okay. So the formula is A positive n minus 1 into D. For the fourth position, it's going to be 3 positive 4 minus 1 into D is 2, which is going to be 3 positive 3 of 2, which is going to be 3 positive 3 times 2 is 6. 6 added with 3 is 9. So 9 is going to be the answer. So we have 9 here. Okay. Let us check the perimeter. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Perimeter is nothing but this region. We have to just go along the outer area. Okay. So that would give us the perimeter, and that is exactly the value. Now what would be the perimeter for 127 toothpicks? So we need to find that value. So I know the position. The value of A is 3 and 127 is not 127. This figure occurs at position number 32. Okay, 32. So it's not 127. So it's 32 there. Minus 1 times the D is 2. So there's going to be 3 positive 31 times 2. So 3 positive, 2 ones are 2, 3 twos are 6, which is going to be 65. So 65 is going to be the solution. Now for n, we have to write the values. So as I mentioned to you, for n, it's the value of A is 3 positive n minus 1 into 4, right? So this is going to be 3 positive 4 times n negative 4, which can be rewritten as 4 and negative 1. So this is going to be 4 and negative 1. And for this we need to get the n value. So this is 3 positive n minus 1 into 2. I'm going to use this side. So this is going to be 3 positive 2n minus 2, which means 2n positive 1. So that's the n value here. So this is 2n positive 1. Okay, so that completes the solution for this question. So we have reached section 2.